Hello everyone and welcome you all for today's discussion. In our previous class yesterday we have discussed about dynamics of fluids. So as जैसा कि मैंने कल कहा था, as I told you yesterday that I will try to finish the remaining part of the kinematics of fluids. That's why today I am going to discuss about what is a rotational motion. Rotational motion, and I will try to cover circularity. Rotational motion and because these two terms, rotational motion and circularity, these are interrelated. When there is a rotational motion, then there will be circularity. How we calculate circularity? So how it is different from rotational motion and circularity, and what is the relation between rotational vector omega and vorticity? Why both are different? Why vorticity is 2 times of the rotation vector? So that we are going to discuss here. So let us start rotational motion. There is one confusion in mind about rotational motion. Rotational motion of fluid particle. What is difference between circular motion and rotational motion? That I want to give a clear example that all circular motion are not a rotational motion. For example, Earth. For example, taking example of Earth. Earth is performing circular motion around the sun, but it also rotates about its own axis. So its motion is circular as well as rotational. For a small distance, you can say it is a linear motion, but for long distance, it may be circular motion. Sometimes river. Suppose river is moving in circular path. So its motion, a fluid particle, we can't say it is a rotational motion of the fluid particle. But when a fluid particle in river is also performing rotational motion about its own axis, then it becomes a rotational motion. For example, you can see in river that sometimes you see eddy currents in rivers. So eddy current is when fluid particle start rotating about its own axis, not moving ahead but rotating about its own axis, then it becomes circular motion. Though water is moving along the linear path, but at some places you have seen that eddy currents are developed. So in that region you can see there is a circular motion, a side rotational motion of the fluid element. When fluid element, while suppose this is a circle, and there is some fluid element. This is a fluid element. It is performing rotational motion, circular motion. So while it is performing circular motion, it is also rotating about its own axis. Then it becomes a rotatory motion. Means while performing circular motion, it is also rotating about its own axis. Then it is a circular as well as rotational motion. So here I want to describe what is a rotational motion. So taking a very small element, it may be about xy plane or xz plane or yz plane. When fluid particle is in xy plane, then it can rotate about its z axis. So here we have to find out omega z and vorticity and xi z, all these terms we are going to discuss. So let us take one small element of fluid and we define the rotational motion. This is a xy plane. And there is a one here you can see, take element A, B, C and D. Take element A, B, C and D. Here velocity is U. Here velocity is along y axis is velocity V. And length of this element AB is dx, and this element is length of this element is dy. So velocity, when we move here, velocity is increasing by the function of y. When we are moving above dy, velocity will become u plus del u over del y dy. Same thing apply here. Due to here velocity v, and when moving along the x direction, velocity is a function of the x. So here velocity will become v plus del v over del x dx. So due to this unequal velocity, you can see due to this because in of these are AB, BC, and CD and DA. In these 4 segments of the element, you can see velocities are not similar, so it may be distort. So suppose a new position is reaching. New position is like this: A, B dash, like this, B dash, C dash, and D dash. So this is a new position, and this angular deformation taking place d theta 1 and d theta 2. These are angular deformation. Angular deformation. When there is angular deformation, the rate of change of angular deformation is angular velocity. That's I want to find here. Rate of change of angular means d theta by dt. Rate of change of angular displacement. This is angular displacement. Rate of change of d theta by dt will become omega. Omega means d theta, rate of change of angular deformation. We want here because it is taking place in xy plane. So this element is rotating about the z-axis. So we will get a rotation about z-axis. Here we want to find rotation of the first omega AB. We will find omega AB. Omega AB means omega AB. This is rotating about this. So here we want the anti-clockwise rotation will taken positive and clockwise negative. This one is a positive and this one will be taken negative. Anti-clockwise positive and clockwise negative. So rotation about AB reaching AB to AB dash. So angular deformation omega AB equal to change in velocity because rotating this element rotating about causing of rotation is because of the V and change in velocity in this arm. This will rotate this one. AB rotating because of the V plus del V over del x dx upon dx. This is a rate of change of this is velocity because meter per second upon meter. So you will get per second. That is a sign of the rotation per second, revolution per second. D theta by d because this change in velocity in arm BC and AD is responsible for deformation d theta 1. So d theta 1 by dt means change in velocity upon dx. Dx means because we know that tan theta equal to this upon this. Tan theta equal to tan d theta 1. Sorry, tan d theta 1 because we have taken tan. You can say tan theta equal to small angle tan d theta can be taken as d theta because angle is very small. It will be equal to this deformation bb dash upon bb dash upon ab. That is I want here. Tan theta. This is nothing but bb dash upon what is bb dash? Bb dash is a change in velocity per second. Change in velocity per second, that is a v plus del v over del x dx minus v. So you will replace v and we get del v over dx. Del v dx will be removed. So del v over del x. So omega AB rotation of AB about z axis, that is equal to del v over del x. And similarly you can find because this arm is also rotating. AD is rotating about this axis. And for rotation of AD, these two terms you can see these velocities are responsible. So omega AD equal to u plus del u over del y dy minus u upon this arm, that is equal to dy. Sorry, here I have taken mistake. This should be dy. This should be dy. This should be dy. This should be dy. So you will cancel out and dy also cancelled out. So w omega ad equal to del u over del y, but sign is negative. Why? Because sense of rotation of AD is clockwise. This sense of rotation of AD is clockwise. So omega AD equal to minus del u over del y. So we have to find out average. We have to find out average angular rotation. Average angular rotation. What will be angular rotation? Average angular rotation, that we will define, because this rotation is about z axis. You can simply write wz equal to summation of 1 by 2 wab omega ab plus omega ad, that is equal to 1 by 2 del v over del x minus del u over del y. So that is omega z. Find omega z equal to 1 by 2 del v over del x minus del u over del y. Similarly, you can, because we have taken fluid element along in xy plane, same you can apply for xz plane, yz plane. So it is better to define the whole up, because we know that we have to define this is a vector quantity. So rotation vector can be defined as wx omega xi plus omega yj plus omega zk, and this we can define omega vector by 1 by 2 curl v velocity vector, and here we can define 1 by 2 I j k del upon del x del over del y del over del z and u v w. These are three components along x direction, y direction and z direction. These three components we can find out easily. So similarly you can find out wx omega x equal to, for omega x I, this will be omega x equal to del omega y 1 by 2 del omega over del y minus del v over del z, and omega y equal to 1 by 2 because here sign will change omega y, this del u over del z minus del omega over del x. So these are three components of rotation along about x-axis, y-axis and z-axis. Combining together, you can find out curl because already in determinants we have already in your lower classes, in intermediate level and in mathematics simple determinants, you can simply find out curl v. In mathematics already everyone are familiar what is it, how to calculate curl v. This is a cross multiplication of del operator multiplied by velocity. Velocity has three components u, v and omega. So simply you can find out w. So w equal to this vector. You can represent all these components in vector form. So w equal to omega x I plus omega y j plus omega z k. There are three components. So similarly you can find out magnitude. Magnitude you can find out omega x square plus omega y square plus omega z square under root. So it is very simple. If values are given in form of x, y and z, you can simply find out if there is a rotational motion, then you can value if flow is irrotational. If flow is irrotational, this value will be equal to 0 for irrotational motion. For rotational motion, you will get some value. For irrotational, if motion is irrotational, this whole value will become 0. Means for irrotational motion flow curl v equal to 0 means w equal to 0. Curl v equal to 0 means rotation vector will become 0. When rotation vector will become 0, its magnitude will also 0. Another thing that I want to define here that is related to vorticity. Another thing that I want to define vorticity. It is also a, because in finding out rotation, because when we find out rotation about z-axis or x-axis or y-axis, we have taken average value of rotation because two components rotating like this and this. So we take average by summing and dividing by 2. But in vorticity, it takes means rotation, not we are any kind of whether negative rotation or pi rotation. We have to take only count what is rotation, means total rotation. What is total rotation? So we will not take average. So wz xi z equal to that is a del v over del x minus del u over del y, means 2 times, that is equal to 2 times of the wz. All values xi z, xi x, xi y become 2 times of the rotation, corresponding rotation, 2 times of the corresponding rotation. So xi equal to xi x I plus xi y j plus xi z. Here xi x equal to 2 times of the omega x, xi y equal to 2 times of the omega y, and xi z equal to 2 times of the omega z. Means xi vector equal to equal to curl v, while W vector equal to 1 by 2 curl V. So this is relation between rotation and vorticity. Means rotation about any sense. We are not considering negative or positive. We are considering not taking average, but we are taking total rotation. That is expressed by the high vorticity, and rotation with sense expressed by taking average of rotation of the two arms. That's why here when we determine, we analyze rotation, then it become half of the curl V, while vorticity become a curl V. So this is a relation between same thing. You can same way you can find out curl V. I, J and K, del over del X, del over del Y, del over del Z, U, V, W. UVW. Find the value of this curl V, that is equal to curl V. You can find this value, you can find out vorticities. These are very simple terms that we want to define. Simply very simple things are there. You can find out numerical values. But this exists only for the rotational flow. When flow is irrotational, these value vorticity, xi vector and rotation vector omega, both will be 0. For irrotational flow, both will be 0. For rotational flow, you will get some values. We will always get some values for rotational flow. But for irrotational flow, when you find a curl V or half curl V, both will become 0 for irrotational flow. So this is a way how you can determine flow is rotational or irrotational. So next thing that I want to determine is we will solve some questions. These questions are very easy. When if you know how to find out curl V, then you can easily find out without making any mistake if you have idea of solving vector curl V. Now the next thing is what is circularity, because when there is a rotation, then circularity. What is circularity in flow field? How we define what is significance of circularity in flow field, that I want to define. Next term is circularity. In a flow field, take a flow field. This is a flow field, any flow field, and circularity can be defined by, this is a, suppose these are streamlines are different because already we have discussed in flow field be defined by streamlines. Take 2 points here, A and B. We are taking 2 points A and B and taking distance of these 2 points DS, and taking as tangent at this point. This is as we know by definition what is a tangent, what tangent showing at any point on the streamlines. This is a velocity and magnitude determined by the tangent at this point. And now we can take this angle is at this point, this angle is theta. So we can take two component of resolving perpendicular component, that will become V sin theta, and this will become V cos theta. Magnitude, we are taking magnitude only, not vector quantity. There are two components of velocity V, and this is V sin theta. So which component is responsible for this circular? Because we are determining circularity. So how you, because we know that A to B ds distance is covered with because of the V cos theta component. Not this component V sin theta is not responsible for circular motion. This circular track is traversed by the V cos theta. So how we define circularity? This is a symbol of circularity, that is equal to integration of tangential component for whole of the path. Integration of tangential component for whole of the path. So this first we define d tau. Let us first define d tau. First we define d tau. Because taking circularity from A to B. Taking circularity A to B means equal to V cos alpha into dot product ds. This is circularity from A to B. Path is traversed by the V cos alpha. Now total circularity will equal to integration of V cos alpha for whole of the circular path. Integrating V cos alpha component for whole of the circular path is a circularity. This is circularity. So this scalar quantity v cos theta, v cos theta for ds is a elemental circularity d tau. Now whole circularity, you integrate v cos alpha ds, v cos alpha ds, a to b ds, v cos alpha for whole of the path means circular integration, you take perform for whole of the circular path, then it becomes a circularity. This is the circularity. So let us define circularity for the small element. Now defining circularity for a small element. Defining circularity for a small element. This is x and this is y, and take here element a, b, c and d. This is u. This is u plus. This is dy and this is dx. A, b, c, d, and same u value velocity here v, and this will become v plus del v over del x dx. Here velocity u plus del u over del y dy. Now according to circularity, we can find out circularity. Again we take anti-clockwise positive and clockwise negative. So circularity for this element will be, because circularity here, this is dx, dy. So circularity can be find out here for the whole of element equal to u dx, and plus v u plus u plus, first taking from a to b. So a to b equal to u. Circularity for means distance a to b, u dx according to definition, u dx plus, now from b to c, that is v plus del v over del x dx into dy. Then c to d, you see that here sign is different, sign is changing, so we take negative sign, minus u plus del u over del y dy into length is dx, so multiply dx. Then again from d to a, again sign is different because we are traversing opposite direction of velocity, so again it will be equal to v dy. And solving this one, so u dx will be replaced by this one, and v dx dy replaced by this one. So you will get value del v over del x minus del u over del y into dx and dy. These two values we get. I think here we have taken okay, dx dy, here should be I think dy, here term was du over dx, it was dy not dx, so you will get this value. So this is a circularity we have, because we have calculated circularity for a small element, so denoted, it is better to denote it by d tau. We have मतलब कि हम इसको टाउ से डिनोट कर सकते हैं फॉर होल, बट टेकिंग एलिमेंट वेरी स्मॉल, एलिमेंटल, दिस इज डी बिकॉज डायमेंशन वी हैव टेकन dx dy, so this is very small, that's why we have taken d tau. So d, this is a symbol of circularity. Now define d tau upon dx dy equal to del v over del x minus del u over del y, that is equal to xi z. Circularity per unit area. This is area dx dy. What is dx dy? Dx dy is area of this element. So circularity per unit area equal to vorticity about z axis. Circularity per unit area. Per unit area is equal to vorticity. If it's simple conclusion, you can say circularity per unit area is equivalent to vorticity. This is relation between circularity and vorticity or rotation. You can say it is 2 times of the w omega z or 2 times of the rotation about z axis, because this element is about xy axis, so rotation will be about the z axis. That's why circularity about z axis is equal to vorticity about z axis, or 2 times of the rotation about z axis. Means circularity per unit area d tau over dx dy is equal to vorticity about z axis, or rotation 2 times the rotation about z axis. This is a conclusion and very simple question you will find in this topic. You have to find out circularity by given conditions we can solve question on circularity. So I think we will solve some questions in our next lecture. We will come here to solve 2 or 3 questions. One question based on the vorticity, one question based on the rotation, and one question based on the circularity, that we are going to discuss tomorrow. Thank you very much for watching, and please share and make a comment on this topic and any topic. किसी भी टॉपिक पर अगर आप लोग चाहते हैं कि आपकी क्लैरिटी नहीं है या कोई न्यू टॉपिक पर आप चाहते हैं, तो यू कैन आस्क मी to prepare video lecture on this topic. I will you are most welcome for that. Thank you very much and have a nice day.